Welcome to today's webinar, announcing AWS CodeBuild, accelerating software delivery with AWS CodeBuild, AWS Code Pipeline, and AWS Code Deploy. Our presenter today is Chris Munns. Chris Munns is the Business Development Manager of DevOps at Amazon Web Services based in New York City. Today with us, we also have David, Frank, and Nick. They will be the webinar moderators who will be engaging with you and answering your questions throughout the presentation. Chris, welcome. The floor is now yours.
Great, thanks everybody, and again, really appreciate you coming here, and thanks again for joining us today. Let's dive right in. So why are we here today? In today's world, software moves much faster than it ever has. It's much easier for startups or for individuals to get started with developing very sophisticated and very complicated applications based on both the technologies we have in programming languages, but as well as cloud technologies like those provided by AWS. Getting your actual software and applications into the hand of customers, things that used to involve people maybe driving to a computer store, purchasing software that came in a box, driving back home and installing it, has now been replaced by models for people installing software on demand, online, over the internet, over mobile networks, you name it, directly to devices that live in people's hands. And so what this means is that for businesses of all shapes and sizes, your ability to move fast is really paramount to A, your ability to fight off disruption, as well as your ability to be successful and to make your customers happy. In order to move fast in this new software world, there's a number of tools that we need. Tools to manage the flow of your software development and release process, tools to properly test and inspect your code for defects and potential issues, and then tools to eventually deploy your applications, and again, whatever they might be doing, such that your end consumers and customers can enjoy those products. And so in today's webinar, we'll be talking a bit about these tools that are available to you today from AWS. Before we get into those tools too deep, though, I want to step back real quick and just kind of give a brief intro into some of the terminology that we use when we talk about software development here at AWS. So at AWS, we see that software development typically has four major phases: source, build, test, and production. And so most of our conversation today is going to be based around this aspect of these four phases. These are probably pretty familiar to you already if you've been developing software for really any period of time. In the source phase, we're writing our code, checking it into a source control service, potentially having our peers or other members of our team or company to review it. In the build stage, we're taking that code then and compiling it potentially into a binary or a package or something like a container image, potentially running things like unit tests or style checkers or performing code metrics on analyzing the code that we have. In the test phase, we're typically taking then that built or compiled asset and testing it against maybe the rest of our infrastructure, testing it against things like browsers or other clients that might interface with it, so things like UI testing, load testing, security testing of our application. And then after we've gone through all of this, we're then looking to actually release our software. So getting our software into production, again, in whatever production might be to you. If you're building a mobile application, production is putting your app out into the App Store. If you're building a web application, it's pushing it out to a web server. And of course, depending on what your application is, production can mean many different things. Going along with these four phases, we also see there being three major process levels across the four of them. The first is continuous integration, this idea that as you are writing your code, you are committing it to some sort of version control system. And then from there on, as the code is being committed, it is then being built. This is different than the model of companies who have maybe had nightly, weekly, or more periodic builds, and the idea that you are frequently applying some level of QA to your application code as part of this process. We build upon continuous integration with continuous delivery. The idea of continuous delivery is that we take the built code or the compiled code or tested code that we have, and then we push it on through the rest of the phases here from test out onto production. And typically you might end up having some sort of a manual gate or approval action or some sort of step that prevents automatic deployment out to production. But again, it's this aspect of taking it from the build phase on out through test phases that basically defines continuous delivery. And then lastly, what we have is continuous deployment, which is really the complete combination of continuous integration and continuous delivery with complete and full automation that would allow a deployment to go out. Continuous deployment is kind of the highest level of perfection you could think of software release management, where you've had a lot of automated testing and you're able to be sure that every time that you commit code to your code repository, because it will be pushed out to your production environment, that it meets the bar of quality that you've set for your product and for your business. So again, 4 different release phases, 3 different release process levels, and again, we'll be talking a little bit about this here today. So one of the main topics we'll be talking here today is about the AWS Code Services. And you'll notice that we sometimes refer to these as code asterisks or code star as we call them. And it basically comes down to the naming scheme that these products have. We have AWS Code Pipeline, AWS Code Deploy, AWS Code Commit, and then our newest service, AWS Code Build, which we just launched a couple weeks ago at our yearly user conference in Las Vegas called reInvent. And so we call them code asterisks or code star again based on this naming scheme. So we're going to talk quite a bit today about Code Build, and then we'll touch a little bit into Code Pipeline and Code Deploy. Code Commit is one service that we're not going to go into too much depth here today, but it is AWS's code revision service. It is a Git-compatible service that you can use to store your code in the cloud in a highly durable, highly secure, highly scalable way. Because it plugs so easily into things like Code Pipeline and the rest of the suite of tools that we have, not going to go too in depth on it today, but we're happy to answer some questions if you have them in the Q&A pod. So let's talk about how these 4 different services actually play out into the release steps that we've talked about before. So again, Code Commit is the service that we have for source control. This is where you would be committing your code into and then potentially reviewing it or passing it on into the build phase as part of continuous integration. Code Build, which is our new service, fits into the build spot, as its name might imply. And we'll get into some depth here about what you can do with Code Build in a moment. In the test phase, this is where we actually have a number of third-party vendors and partners, as well as there being an incredible amount of open source and also third-party tools that exist that you can plug into your application lifecycle management flow to test your application in whatever ways it might be. So maybe you're building, again, a web application and you want to test your UI. Maybe you're building a mobile application and you want to test your mobile app. Maybe you're building an API-based application and you want to test your API. Across all the various different ways that you could be building your application, there are lots of third-party tools that are available to integrate with that and perform that duty for you. And then lastly, when it comes to production, we have Code Deploy. So Code Deploy is a tool that you can use for deploying your code either onto AWS or off AWS, whether that be on-prem, or potentially to like another AWS region even. And then what sits on top of all of this is AWS Code Pipeline. So Code Pipeline you can think of as the orchestration service across all of these other AWS services as well as these third-party tools. And again, we'll talk a little bit further about Code Pipeline here as we go on through today. So let's talk about building and testing your applications with Code Build. So AWS Code Build, again, is our newest service in this suite. We just announced it and launched it just shy of about 2 months ago now at our AWS reInvent conference. So Code Build is a fully managed build service that allows you to compile source code, run things like unit tests or other code inspection tests, and then after the fact produce a software package if necessary based on your application. With Code Build, you don't have to manage any sort of infrastructure. So you don't have to run EC2 instances. You don't have to manage containers. There's really nothing that you have to take on from your side and upkeep and maintain. Code Build will launch infrastructure on your behalf, scale continuously behind the scenes, and allow you to process multiple builds as they come out from your organization. So again, it's not the type of a thing where you have to worry about being constrained based on capacity that you're managing. You can actually, with Code Build today, create custom build environments. So we announced the service with a number of pre-built environments based in Docker containers in certain languages. You can actually build your own Docker container and supply it to Code Build, and this can help streamline the build process, help install tools that you might have or other frameworks or things that you might need as part of supporting your build process. One of the greatest aspects about Code Build is its incredible low cost. So you only pay by the minute for the resources that you use. And again, this ties in with the idea that it is a fully managed service for you and that it scales continuously and automatically as you're building your code. So this pay-by-minute model, again, means that you don't have to worry about any sort of upfront capacity planning or commitments or payments for the service. And I'll talk a little bit about this later, but we launched CodeBuild with integration both for CodePipeline and for Jenkins, the very popular open source continuous integration service. So how does CodeBuild actually work? It's really pretty straightforward. It downloads your source code. It then executes the commands that you specify in what's called a build spec file inside of temporary compute containers. So we create a new container and fire it up for you on every build, and then we tear it down when you're done. It takes the output from this build and centralizes it into CloudWatch logs as well as the service's backend so that you can view the log information and other outputs from the build. And this is important given that we do tear down the container after your build. You would want some way to understand what is happening here. And then lastly, CodeBuild has the ability to automatically upload a generated artifact to S3, but as you'll see here in a moment, you could actually tell CodeBuild to put a built artifact almost anywhere, including if you have artifact stores, container registries, or other places that you might want to store your code. So how can you automate your release process with CodeBuild? So CodeBuild isn't meant to be a tool that will automatically look at your code for you as you commit it. Instead, you typically are going to plug it into another tool. So CodePipeline can be used for the continuous integration delivery aspects of being attached to things like an S3 bucket, a GitHub repository, or a code commit repository, and then be used to drive work into CodeBuild. You could also call CodeBuild from other tools. So you could hypothetically build CodeBuild into other processes or other tools that you have around your application lifecycle management. Again, you could bring your own environments, which means you could pre-create Docker containers that have the tools that you need to test and build your code. And then lastly, we released a Jenkins plugin. And so Jenkins is an open source tool for continuous integration. It's used by many enterprises and many companies of all sizes. And so what this plugin allows you to do is instead of having to maintain and manage Jenkins worker nodes yourself or worker containers or whatever you might want to call them, you can actually use CodeBuild as the worker off of Jenkins. And so this helps make things a lot easier for you when it comes to the management of, say, a large sophisticated Jenkins environment as well. So I mentioned that with CodeBuild, there is this concept of an instruction file that is used to tell CodeBuild what to do when it's building your code. So we can see here an example of a buildspec.yml file. And won't expect you to be able to read through all of the components here, but what I do want to cover is the fact that there are essentially three main sections to this build spec example file. The first is the concept of environment variables, pretty straightforward environment variables which will be used by the processes and the commands inside of the main phases section of your build. The next is the definition for those phases. So today we have 4 predefined phases that exist inside of a build execution. So we see install, pre-build, build, and then post-build. And you can run many different commands inside of these. You can use these commands for bootstrapping and installing software inside of the container when it first launches. You can use these to do things like running unit tests or running lint or syntax checkers or kind of any sort of command that you might think of as part of your build. And then lastly, in the post-build, this is the type of place where you maybe, after you've created a container image, would ship that off to a repository like ECR. And then at the bottom here is the artifact section. And so we see a definition around the type of artifact that we're going to create. Today we support zip files or just a list of files that are not part of a zip. We then can target the files that we want to specify as part of this artifact, and we can do things like discard, delete, and paths for that as well. So number of capabilities here, but you can imagine as part of this the ability for you to run almost any command that would be necessary for you to build, compile, test, what have you of your application. It's a pretty open and pretty flexible environment. So when we talk about building your code, what exactly does this mean? And sometimes this is a question that I'll get. So building your code typically refers to languages that require compiled binaries. This is .NET languages like C#, VB.NET, F#, other languages that are part of the .NET suite, Java and JVM related languages, so Java itself, Scala, JRuby, Go, iOS-based languages, so Swift, Objective-C. We also refer to the process of building a Docker container image as building the image. There are, however, many languages that don't require building. So languages like PHP and Ruby, Python, and Node.js are languages that you'll typically just use a service like CodeBuild for the testing aspects of inspecting the code and making sure that the code meets a certain quality bar for your organization. So when it comes to testing your code, though, this is another area that I find there's often some confusion as to what you might do inside of a tool like CodeBuild versus potentially further out in the pipeline. So, testing your code is a fairly complicated thing often. There's a number of things that you want to get out of testing your code inside of a service like CodeBuild. So you want to obviously confirm desired functionality, and that's typically done via things like unit tests. You want to catch programming syntax errors, which can be caught via unit tests or syntax checkers of your language or linters. You might want to standardize on code patterns. So many organizations will establish a programming syntax and pattern for what they're doing, such that developers reading other developers' code will have an easy ability to be able to clearly read and understand what's going on in that code. And then obviously as a part of this, you want to reduce bugs due to non-desired application logic and usage. And typically, again, this is where unit testing comes in. And then lastly, as companies move towards continuous integration and delivery, bringing the security process into the development process via continuously inspecting the code to make sure that it is secure or that it meets certain security concerns and standards is also now becoming a very big part of how companies are thinking about building and testing their code. So again, you want to think of all of the various aspects that you would do at the code level with a service like CodeBuild. When it comes to testing your code and testing your applications, there's a lot of different models and a lot of different thoughts that go into it. One that is fairly popular in the industry is this concept of the test pyramid. What the test pyramid basically talks to is the idea of where you want to spend your time in testing your application in terms of coverage as well as just your general focus. So one of the kind of rules of thumbs that comes with this is the idea that you would spend about roughly 70% of your testing time at the unit level, so actually inspecting raw code with unit tests, about 20% at the service level, and then about 10% at the user interface, again, whether that be a web interface, a mobile application, or an API-based application. If we were to think about how that aligns with our release steps and with our phases, what we see here is that CodeBuild, again, is the place where typically you're going to run unit tests as part of the build phase, and then via third-party tooling is where you would, in the test phase, then take on, again, things like UI testing, service testing, whether it be via stubbed interfaces or something similar. And so while you maybe don't want to be super analytic about where you're spending your time in this and maybe not measure it to this exact degree, it's still important to have a good idea of understanding where you should be spending your time and making sure that you have as close to these types of ratios of coverage as possible. In terms of pricing, so again, CodeBuild is a really advantageous service in the fact that you don't have to prepay for anything. You don't have to have infrastructure waiting around for code to show up at it. It will spin up infrastructure on the fly for you as a build is executed, and then you pay by the minute for the duration of that build. So if you commit code and kick off a CodeBuild job and it takes 10 minutes for your applications or your application's build process to complete, then you're going to spend the price equivalent to the 10 minutes based on the size of the instance that you choose. And so we do make this instance size based. So you can see here in the chart in the middle of the slide, we have currently today 3 different types of instance types, and they correspond with memory and CPU quantities for each of them. And if you notice, they also kind of tie back a little bit to EC2 instance types to a small degree. And we're always looking for feedback on this. So if you feel like you need larger instances or instances with different memory or CPU, we're super eager to understand what those needs might be from you. And we'd love for you to pass that into the Q array or pass it on to the team via things like the AWS forums. There is a free tier for CodeBuild, so today you get 100 build minutes per month, which should cover actually quite a lot. And we've heard a lot of positive things about that. So that kind of covers the general intro to CodeBuild. I'll show it in motion here in a little while, but I want to kind of get on to some of the other services that we have. So we'll talk next about actually deploying your applications. So when it comes to the CodeStar suite, again, we have Code Deploy. Code Deploy is a service that is used, again, just really for deployment. So it automates your deployments to any instance, both on AWS or off AWS. It is an agent-based service, so you install an agent on your host, and then that agent talks to our backend. It helps kind of reduce the complexity in updating your applications, and we've designed Code Deploy with the idea that it will enable zero downtime deployments. Code Deploy is actually based off of an internal tool that we have here at Amazon that was built with the same goal in mind, with the idea that we can't take down Amazon.com just to deploy a new version to it. And so Code Deploy has a number of capabilities built into it to enable this zero downtime aspect. Code Deploy also supports the ability for automatic rollbacks. I'll talk a little bit later here when I get to some tips and tricks on how automated rollbacks is actually one of the most key things that AWS and Amazon developers will do as part of their DevOps operations. So anytime that a failure is discovered, instead of waiting to triage it and figure out what went wrong, we immediately roll back to a last known good application version. I already kind of mentioned this, but you can deploy CodeBuild either on AWS or off AWS. Awesomely enough, I actually have a coworker who got it to run on a Raspberry Pi once. So there's lots of different places that you can run Code Deploy and lots of different pieces of software that you can install with it. And then lastly, it integrates with a lot of third-party tools. So it has integration with Code Pipeline, but it also has integration with Jenkins, with GitHub, and with a number of other CI and CD tools and services that are out there. So if you do have some existing tools today, you have the ability to go and integrate that with Code Deploy. So Code Deploy, much like CodeBuild, or realistically CodeBuild, much like Code Deploy, is based on an instruction file that you place inside of your code repository. In this case, for CodeBuild, the instruction file is called an appspec.yml. With CodeBuild, it was buildspec.yml. And with this file here, much like the build spec, there are a couple of sections that we want to be aware of. The first is a files section. It's pretty straightforward. It's a pairing up of source and destination directory pairings or file pairings that would exist on from the source artifact out to the destination host. And you can actually have multiples of these inside of a single app spec, so potentially you could ship some files to one part of your operating system or on your disk and some files to another place, like potentially taking a configuration file and putting it in the config directory and then putting your actual application code in the application directory. Below this we have permissions, so this aligns with the permissioning system of the OS that you're using. We can do pattern matching, we can do specific files. There's a number of things that you can do here. And where this becomes really beneficial is that often as part of developers working through their application development or as part of the build process, you might lose some of the permissioning that you might need to have on your end environment. And so this allows you to specify it as part of a deploy. And then lastly here, one of the most interesting parts and most useful parts of Code Deploy is this concept of application lifecycle hooks. So the application lifecycle hooks that we have are useful for when you need to do things on the host beyond just shipping the bits. So we see a number of examples here across 4 of the 5 hooks that we actually have in Code Deploy. We see a script that is being called to register ourselves from an ELB, a script to install dependencies, a script to then start our web application service, and then a script to test our site, and then to re-register ourselves with a load balancer. And so realistically, you could run pretty much anything that you could think of that could run in a shell environment or on a command line on the end host, whether it be Bash in Linux or PowerShell in Windows, a Python script, a Perl script, anything you can really think of, you could execute as part of your Code Deploy action. Another part of the magic for what Code Deploy does and how it can help enable zero downtime deployments is that it gives you the ability to select the speed at which you deploy across your instances. So we see here an example of 3 different speed possibilities, 1 at a time, half at a time, and all at once. In this case, you as the developer or as the operations person using the service get to pick the speed and define any integer or percentage-based value that makes sense for you. And then what happens is Code Deploy will queue up work only for enough instances to match that speed at any given point in time. So going back to the previous example of the appspec file that I had, I could, inside of my appspec file, be removing my instance from a load balancer, doing what I need to install my software, and then reattaching it. If I'm slowly sweeping through a pool of hosts as shown here in the 1 at a time speed, That would allow me to potentially not impact customers that are on the rest of the instances, and then allow me to just quickly slice through all these instances one by one, moving them from traffic, updating them, and then putting them back into traffic. And so again, based on your application, based on the traffic that it gets, you determine the speed and the workflow involved. The other thing that Code Deploy does, which is really awesome, is how it can target your instances. So it can target instances either via tag or via auto-scaling group. What's really exciting about the auto-scaling group methodology is that when you have new instances that come up as part of an auto-scaling group, say due to a scaling action or a healing action for your fleet, it will actually go and look and say, okay, what was the last successful deployment to this pool of instances? I'm going to do that deploy. So it helps simplify your ability to not need to, say, bake your application code into an AMI, because Code Deploy will pull it down for you. So let's finish up here in talking about the services with how you would orchestrate and build a deploy pipeline. So Code Pipeline, which I've already talked about briefly, is our continuous delivery service. It allows you to model and visualize your software release process, and then gives you the ability to plug into tools that would allow you to build, test, deploy your code anytime that there is a change. It integrates with a number of third-party tools as well as AWS services such as CloudFormation, Elastic Beanstalk, OpsWorks, Lambda, obviously the rest of the code suite, S3, and gives you the ability also to write custom actions that could interface with it. Our plugin that we have today for Code Pipeline for Jenkins is actually based on that custom interface. And so there's pretty much limitless options in terms of what you could plug into Code Pipeline via the custom action as well as via the Lambda interface to Code Pipeline. So this is a visualization of a code pipeline. What we see here is that this is the entirety of the pipeline. The pipeline is made up of stages. A stage is then made up of actions. And then stages are connected via transitions, which can be enabled or disabled. We support the ability for you to do parallel actions. We also support the ability for you to do sequential actions as part of your pipeline's execution. And then lastly, we support the ability, or not lastly I should say, but we also have the ability for manual approvals. And so a manual approval is really useful if your organization still has manual steps that need to be done as part of the testing of your application. Maybe there's a QA team that hasn't been able to automate what they've done yet, and so they need to visually inspect something. Or maybe you need to do it as part of separation of roles and responsibilities to have someone else come in, review what's going to change, and then approve that change or maybe the promotion up to a production environment. There's lots of different things that you can do with the manual approval capabilities. So pretty straightforward here, and again, Code Pipeline meant to be a visual service that is very much an orchestration across all of the other capabilities that we have. So I'm going to get into a little bit of a demo here. Just because I don't like to tempt the demo gods too much, I've actually done this demo via screenshots. So my apologies for not being a live demo, but just due to the nature of how webinars work, I felt that it might be a little bit better for me to do this via screenshot. So what is this demo going to show? So we're going to start with a repository. Last year we released a repository on github.com in AWS Labs organization called AWS Code Deploy sample Tomcat. Not the most exciting repo name, I admit. What I've done is I've taken this repository, I've added a build spec file to it, which I'll show you. We're then going to walk through creating a pipeline with a source and a build stage, and then we're going to do a build. So we're going to basically just show you what continuous integration would look like using these two services. Then we're going to add a deploy stage, and then we're going to do a full execution and a deployment of our application via the pipeline. So essentially taking the CI and then adding continuous delivery to it. So you can go out actually and fork this repository yourself. Again, if you go to github.com/AWS/AWS-code deploy-sample-tomcat, or you can just go to github.com/AWS Labs and search for the words code deploy and Tomcat, and this should come right up. What you'll see here in this repository now is a build spec file. And I want to show you just how minimal of a build spec file we need to get started. So the build spec file that exists right now is this right here. So if you look at this build spec file, GitHub's interface tells me that this is 11 lines. 2 of them are just blank space lines. But if you look at the rest of this, this is incredibly simplistic. In fact, I throw out an echo message in here just to kind of be nice. So we could remove that, and realistically this becomes a 10-line file with 2 of the lines being just blank spaces, and the rest being just kind of very straightforward syntactical structuring of the actual build spec reference itself. And then this is all that I need to be able to compile this Java application inside of CodeBuild. Next, I would go into the code pipeline web interface. I'm going to create my pipeline. In this case, I'm giving it the name of just CI, which we'll find out later maybe wasn't the best of naming given that we moved beyond CI. I'm then going to select my source provider, which I've selected GitHub. Now I have forked the repository from the AWS Labs account, and I have just a master branch for it, so I selected those. For my build now, I'll show you here what I've done, and all that I've really done is name my project, pick my source, and then left almost all of the rest of the defaults in place here from the code pipeline interface. So as we scroll through here, I'm using the managed AWS build environment, picking the default OS runtime, the default language, and creating a role and leaving it at the base compute type. And that's basically it. There's not a whole lot that I need to do to configure CodeBuild for it to compile my application. From here, step 4 of my pipeline creation, I'm actually going to go with node deployment initially. Step 5, creating a service role. And then step 6 is to review this. And so again, in reviewing this here, what we'll see is I have a source stage, which is my Git repository. I have a build stage, which is my code build environment that I have set up. I have no beta stage, so no deployment stage. And then kind of the bottom here of my pipeline settings. And so I click Create Pipeline, and then what comes out of this is a created pipeline. So when you create a new pipeline inside a code pipeline, it will immediately execute. So what we see here on the left is that my pipeline has begun executing. So it pulled down my source from GitHub, and then it's passing it on to CodeBuild. And very quickly, within a number of minutes, my build is completed. So again, what you see right here is a pipeline that represents just continuous integration, taking my source code every time that I commit a change to it and building it, and then the build step actually puts an artifact into S3. What I could do here, if you look at the pipeline that's kind of in the middle of the slide, you'll notice that there is a underlined bit of blue text that says details in the code build stage in action. I can click on that details link and jump right into the code build execution and build history for the build that was passed in from my pipeline. And it's here that I can see a bunch of information. I can see what the source provider was. In this case, it was Code Pipeline that fed into CodeBuild. I can see the initiator, the name of the pipeline. I can see the start time, the end time, and I can see an Amazon resource identifier here, the ARN of this build. I can then also jump down into the build details and the phase details and see everything that happened as part of this build. So in this case, again, it's a pretty basic build, but then down at the bottom here, I could actually scroll through the build logs that exist. And so in the console for CodeBuild, we expose to you the last 20 lines. But you'll notice here again a link that I can click on that says View Entire Log. In this case, because we've captured all of the logs and sent them to CloudWatch Logs, I can now go back and look at my build logs. Had there been a failure, I can come in here and search for the error and understand what went wrong, potentially hopefully correct it, and then move forward from here. But this gives me the ability to see all of the output from my build action. Great, so again, very quickly here, we started with a code repository. We added a build spec file to it, which was really just about 8 lines of code. We've created a pipeline, which was just a couple of clicks in the code pipeline console, and we've been able to do a build just actually based on the fact that the code pipeline existed. So now we're going to add a deploy stage and do a full execution. Well, one of the things that we're going to need in our application is an appspec file. And so there's been an existing appspec file for Code Deploy inside of this repository. I'll show it to you now. So it's a pretty straightforward appspec file. My apologies for some weirdness here in the screenshot showing the URL bar to the right. What we see here is the file section. So there's really 2 files that I'm going to take from my source artifact and put them onto my destination host into certain areas. And then I have 4 hooks that I'm making use of with 5 scripts altogether. So first I'm going to stop my application. In this case it's Tomcat application. I'm then going to install my dependencies. I'm then going to write a config file. I'm then going to start this application, and then I'm going to do a very basic health check. And it's part of this validate stage, or validate hook, I should say, that is the last step as part of this deploy. And if that passes, then the agent will reply back that there's been a successful deploy. So what we see here is now me going back into the code pipeline console. I've clicked on the edit button, and now I am adding a stage. And then as part of that stage, I'm adding an action, which is the deployment provider of AWS Code Deploy. I then have already existing a configuration for an application name and a deployment group. And then further on down here, and again, my apologies for some screenshot weirdness, I have the input artifact, which is called my app build, which is coming from CodeBuild. So from here, I can click add the action in the bottom right corner, and then I have now added this stage and added this action to my pipeline. By going back and saving this, what I end up with here now is a 3-stage pipeline where each stage has a single action, and I can go back up and say release change, in which case my pipeline will execute again. And so we can see here from the left that it has started going through the execution after completing the build, and then on the right here we have had a successful deploy. So again, here in this demo, we started with the repository, we added a build spec file, we created a pipeline then that had a source and a build stage, we did a build. We then added a deploy stage and then did a full execution of that pipeline. Well, what happened from here is that anytime that I made a change to my GitHub repository, it would automatically kick off a pipeline execution, which would grab my source code from GitHub, put it into S3 into an initial artifact, take then that code, from there kick on a code build execution, which would grab that source artifact, bring it into the container image, execute the buildspec.yml, output a file back into S3 at the end of it, and then pass on in the pipeline the next action and stage, or stage and action I should say, which is code deploy. Code deploy agent on my instance is pulling its backend. It sees that there is a deploy action. It grabs the deployable artifact, opens it up, looks at the appspec.yml, and performs what it needs to do to install my application, and then I am done. So, bunch of complexity behind the scenes, but as the developer or as the user of these things, not a lot of work that you have to do in order to enable CI and CD for your application. So I'm going to talk through generally here just a couple of best practices and things that we recommend about using these products and about kind of overall developer workflow at Amazon. So for us here at Amazon, CI and CD is a must. Our developers are committing frequently. We build on every single commit. We only build once though in a given execution flow, and then we almost always deploy to some sort of dev or staging environment for further testing. Again, getting us all the way up through the test phase of the 4 phases that we had of application deployment. Everything that is code, so our application, our infrastructure, our documentation, goes into a repository. Essentially, if it's not in a repository, it doesn't go into a production environment. And then when you're starting off with continuous delivery, start with a gate or some sort of a manual approval until you've been able to really build up enough evidence and confidence in the testing and the automation that you have in place to completely allow your code to go all the way out to production. But by putting that approval step in place, you do have the ability to at least know that you don't have to worry about code, shooting out to production before it's ready to be to go out there. And then lastly, we have certain models, and we encourage these around as well, about when you do deploy out to production and you do have an important production application, there's a number of different ways that you can do the deploy such to minimize any sort of impact to your end customers. We make use of something called canaries. This is typically an instance that is part of a production application fleet that we will throw both real and synthetic traffic at to prove that there haven't been any issues in our application that our code testing hasn't caught. So we deploy to a canary, and then we'll test. And then we'll deploy to a single AZ, and then we'll test. And then we'll deploy to the rest of the region, and then we'll test. And we'll typically do this as we roll globally for our services so that it is not just a single button, single deploy that could impact all of our customers globally. And we find that this is a pretty good way to control any sort of blast radius around what could be a potential impact to our customers. Some other things that we do. So we really encourage code reviews. We find that code reviews are one of the best mechanisms for what someone might call good code. So does this code look clean, and can someone else read it and understand it, right? Has this person used good coding standards? Does it meet the needs of the expectations of what this code has been built for? So is it going to solve the problem, and is it going to solve it well? And then lastly, are there improvements that could be made? And so we'll pretty typically have a code review done by another member of the team for most changes that we make. We also make heavy use of style checkers. So we want to make sure that the code that one developer is writing can be read again by almost any other developer who works in the organization without them having to really think hard or understand how this developer might have, done things like variables, spacing, other syntax, things like that. Auto rollbacks, again, we feel are probably the quickest recovery mechanism after a failure. So if you notice that something has gone wrong, you have an alert that's been triggered, the reaction from that alert should actually immediately be a rollback and then investigation into what went wrong. And if you're collecting logs and you have other metrics and data, hopefully you have the ability to pull that up. And then lastly, very thorough dashboards. So what is it that's happening now? What does normal look like over a given period of time? How do I know by looking at this graph if an alarm has been triggered or if something has changed? And then lastly, based on all the graphs that I have, is they're basically anything that I can tell that correlates with the failure that I've just seen. And so very thorough dashboards are a big part of what we do. So lastly here, in terms of talking about the CodeStar services, there are some tips and tricks that apply directly to these. The first is that all of the CodeStar products can and should be provisioned and managed with AWS CloudFormation. So with CloudFormation, which is another AWS service that we have, you create template files that are used to provision and manage AWS resources. And you can use these for both the initial creation and then the ongoing maintenance of these resources. One thing that's really interesting is that we actually support CloudFormation inside of Code Pipeline. So you can actually build a pipeline with CloudFormation that is then managing your CloudFormation stacks and resources. So it's a little bit of CodeStar inception, but it's something that you can very easily do. All of these services have very deep integration with IAM, or Identity Access and Management. And so you have the ability to be very fine-grained in terms of the permissions that you assign to different developers or users inside of your organization. So who can commit code, who can approve manual approvals, who can deploy to certain environments and groups, who can modify or update any of these services configurations. All those things you can control and have very fine-grained policy and access on. And then lastly, you can integrate these services with Lambda to do all sorts of things. So Code Commit has a concept of repository triggers that you could use to call Lambda to talk to other services or to do certain things with the application code. Code Deploy has event notifications around success or failure of actions that happen as part of a deployment. And then Code Pipeline gives you the native ability to invoke Lambda functions as part of your process, which could be used for calling third-party APIs, running other tools, interfacing with things like run command, which can be used to execute commands on other hosts, lots of different things. So lastly here, just kind of summarizing about CodeBuild, again, the newest service that we have here in the CodeStar suite. It's a fully managed service. So again, you don't have to worry about provisioning instances or servers or thinking about their availability or AZs or anything like that. AWS CodeBuild takes care of all of the aspect of the setup, patch, update, and maintenance and management of those servers and instances. There's continuous scaling as part of this, so you don't have to worry again about the aspect of running into capacity issues and the aspects that would come if you were typically managing any of this infrastructure yourself. So again, this gives you some peace of mind to not have to have this overhead. And then as well as this, it's a pay-as-you-go model. So again, no upfront, no long-term contracts, nothing that you have to think about in terms of the aspect of payment. Because of the pay-as-you-go model and the incredibly low cost for CodeBuild, it becomes a really great service again for kind of integrating build and test of all sorts of code, maybe that you would not have typically have tested. It's very extensible, so we've seen how via the fact that you can bring your own Docker containers and how inside of the structure of the build spec file you can call almost any command or program or script or tool that you would want to that can run inside of the Docker container. So again, being able to model around what your workflow is should be very straightforward. And then enables you to do CI and CD via integration with things like Code Pipeline and Jenkins. And this, again, makes it much easier for you to tie directly into your source control systems and into anything around the automation of when code is committed automatically being built, so really enabling the CI flow. And then lastly, because of its integration with IAM and the fact that when we create artifacts it can tie in with KMS, you have a very high level of security. One of the common things that we hear about other continuous integration systems is the difficulty in securing them. Because we create a container image for you and then tear that down when it's gone, because of the very fine-grained resource management controls that come with IAM, you have quite a lot of bits of opportunity to secure this environment for your users and for your organization. Want to encourage you to know about information and places where you can go to get more resources. So AWS and Amazon.com/DevOps is the landing page that we have for all of the DevOps services here at AWS, including the CodeStar products, CloudFormation, Beanstalk, OpsWorks, Config, CloudTrail, and X-Ray. And off of here you'll find links to things like our DevOps blog. So the DevOps blog has a number of articles around the capabilities of these products, interesting things that you can do, partners that we work with, other tips and tricks, and so keep an eye on this as there's kind of content coming every couple days to this. Again, want to thank you very much for joining us here in this AWS webinar. We will be sharing this recording with everyone here in the coming days into next week. We're now going to switch over to some live Q&A, so I'm going to try to catch up on some of the questions that have been asked. But we really want to thank you for your time, thank you for your attendance, and hope you have some fun building, writing, and deploying code with the CodeStar services. Thank you again.